All right, so get this. You sent us some fascinating research on something called the cold spot.
The cold spot.
Yeah, and let me tell you, it's
Okay.
going to get really cool.
Right.
Literally, we're talking about this mysterious patch in the universe's background radiation
Yeah.
that's significantly colder than everything else.
Right.
And today, we're diving deep into some of the most mind-bending theories
Right.
scientists have come up with to explain it.
Right.
From glitches in our instruments to, wait for it,
Yeah.
collisions with other universes.
Wow.
By the end, you'll have a front row seat to the debate and can decide for yourself what
Yeah.
you think is going on.
Sounds good.
So to understand the cold spot, we first need to talk about this background radiation.
Right.
What is it and why does a cold patch even matter?
Well, you're right. It all goes back to the cosmic microwave background radiation, or CMB.
CME.
Yeah, it's basically the leftover heat from the Big Bang.
Mm.
This faint echo that's been traveling through space for almost 14 billion years.
Wow.
And what's incredible is that it's almost perfectly uniform in temperature, which tells us a lot about the early universe.
So this uniformity is like finding a perfectly level floor in a giant ancient house.
Okay.
It tells us something about how the house was built.
Right.
But then we stumble upon this cold spot.
Yeah.
And it's like finding a hidden trap door.
Exactly. The cold spot is this massive area about 1 billion light years across.
Wow.
That's noticeably colder than the rest of the CMB. Its existence throws a wrench into our neat picture of the early universe.
Yeah.
And forces us to ask, what could have possibly caused this?
Okay, so let's get to those theories.
All right.
Some are fairly straightforward, while others are, well, let's just say a little more out there.
Yeah.
What's the simplest explanation?
Well, one possibility is that our instruments or data analysis are slightly off. It's like thinking there's a dent in your car, but it turns out it was just a trick of the light.
But I imagine scientists have double and triple checked the data by now.
They absolutely have. Scientists are meticulous.
Right.
And they've been studying the cold spot for years, using different telescopes and techniques. While instrument error is always a possibility,
Yeah.
it's becoming less and less likely as the primary explanation.
Okay, so if it's not a measurement fluke, what else could it be?
Another idea is the cosmic texture hypothesis.
The cosmic texture hypothesis.
It suggests that the universe, much like a fabric, might have some wrinkles or imperfections in its structure.
So you're saying it's like finding a snag in a giant cosmic tapestry.
Exactly.
It's not a hole, but it does disrupt the pattern.
Yeah, and if this hypothesis holds, it means our understanding of space-time itself might need a bit of revision.
Wow.
Now, another theory proposes that massive clusters of galaxies
Okay.
between us and the cold spot are affecting how we perceive its temperature.
Okay.
It's called the cluster hypothesis.
Wait, how can galaxies mess with our temperature readings from billions of years ago?
It's due to something called the Sachs-Wolf effect. Imagine you're throwing a ball uphill. It loses some energy and slows down.
Okay.
Similarly, light from the CMB loses a bit of energy as it travels through the gravitational fields of these galaxy clusters.
Oh.
This energy loss can make the region appear slightly cooler than it actually is.
Interesting. So it's not that the area is inherently cold,
Right.
but rather that the light from there gets a bit tired on its way to us?
Yeah.
But hold on, I remember reading that there's this giant void,
Okay.
a super void,
Yeah.
in the direction of the cold spot. Could that be causing the temperature dip?
That's the supervoid hypothesis.
Super void hypothesis.
The idea is that this vast, empty region of space between us and the CMB
Okay.
could be affecting the temperature readings. You see, when light travels through a supervoid,
Yeah.
it actually gains a tiny bit of energy as it exits, making the area behind it appear slightly colder.
So it's like a reverse Sachs-Wolf effect.
You got it. However, recent studies have shown that the observed supervoid isn't large enough or empty enough to account for the cold spot's temperature difference.
So that theory might be out the window.
Well, not completely.
Okay.
Just means that particular supervoid isn't the culprit.
Okay.
There's still a chance that other, even larger supervoids could be involved. It's a cosmic mystery that keeps unfolding.
All right, so we've gone from measurement errors to cosmic wrinkles to tired light and even cosmic voids.
Yeah.
I'm getting the sense that things are about to get even wilder.
You're catching on.
Uh-oh.
Buckle up, because we're about to explore a theory that's truly mind-bending.
All right, so let's talk about this mind-bending theory you mentioned.
Okay.
It has something to do with the multiverse.
You guessed it.
Okay.
It's called the multiverse collision hypothesis.
Multiverse collision hypothesis.
And it suggests that our universe
Okay.
might have bumped into another universe billions of years ago.
Hold on. Other universes?
Yeah.
As in more than one universe?
Yeah.
I thought that was just like a sci-fi concept.
It might sound like science fiction,
Yeah.
but the idea of a multiverse is a serious contender in modern physics. Imagine it like this.
Okay.
You know how a single drop of water can split into multiple smally droplets?
Yeah, like when it splashes on a hot pan.
Right. Well, some physicists think that the Big Bang, the event that created our universe, might have been like that initial splash,
Okay.
creating not just one universe, but a multitude of them. And these universes might exist alongside ours, each with its own unique properties.
Okay, I'm trying to wrap my head around this. So
Yeah.
you're saying there could be countless other universes out there?
Right.
Maybe with different laws of physics, different histories, maybe even different versions of ourselves running around?
That's the general idea.
Whoa.
And the cold spot, according to this hypothesis,
Okay.
could be a bruise left over from our universe colliding with another one in the distant past.
So like a cosmic fender bender.
Exactly. Now, I know this sounds incredible, and trust me, there
Yeah.
are plenty of skeptics.
Yeah.
But what's interesting is that the multiverse idea actually fits quite well
Okay.
with some of the most fundamental principles in physics, particularly quantum mechanics.
Quantum mechanics. Oh, I remember struggling with quantum mechanics in college.
Right.
That's the realm of the very, very small, right?
Yes.
How does that tie into something as massive as a universe colliding with another?
Quantum mechanics is all about probabilities and possibilities. It suggests that at the subatomic level,
Okay.
particles exist in a fuzzy state of multiple possibilities
Okay.
until they're observed. It's like flipping a coin.
Yeah.
Until it lands, it's both heads and tails simultaneously.
So you're saying that in the quantum world,
Yeah.
all possibilities actually exist?
Exactly.
Wow.
And the multiverse idea takes this concept and scales it up to the level of entire universes.
Okay.
It suggests that all those quantum possibilities might manifest as separate universes. Our universe, the one we experience, is just one of these possibilities.
Wow. That's heavy stuff.
I know.
But if these other universes exist,
Yeah.
wouldn't they be completely separate from ours?
Right.
I mean, how could we even detect them, let alone collide with one?
That's the million-dollar question.
Yeah.
Detecting other universes directly is a challenge, to say the least.
Right.
But if our universe did collide with another,
Okay.
there might be some subtle traces left behind.
Okay.
Think of it like looking at the rings of a tree. Each ring represents a year of growth, a record of the tree's past.
So you're saying that the universe might have rings or traces
Yes.
that reveal its interactions with other universes.
Precisely. These traces could be extremely subtle, but they could manifest as unusual patterns in the cosmic microwave background radiation,
Okay.
variations in the distribution of matter, or even anomalies in the fundamental constants of physics.
So we're essentially searching for cosmic scars that tell a story of a long ago collision.
Yes.
Wow.
And the cold spot, with its unusual temperature dip, could be one such scar.
Okay.
Of course, proven this is no easy feat.
Right.
It requires a combination of meticulous observation, sophisticated data analysis, and the development of theoretical models
Okay.
that can accurately predict the signatures of a multiverse collision.
I'm sensing a butt coming.
Well, even if we find these scars,
Yeah.
not everyone will be convinced. Some scientists argue that the cold spot could be a statistically unlikely, but ultimately natural fluctuation in the CMB. And even if we rule out those conventional explanations,
Yeah.
proving the multiverse is a whole other ball game.
So it's like finding a mysterious footprint on a deserted beach.
Yeah.
We can speculate about what creature made it,
Right.
but without seeing the creature itself, there's always room for doubt.
That's a great analogy.
Thanks.
But even if we never get definitive proof, the quest to understand the cold spot, and by extension, the possibility of a multiverse,
Yeah.
is pushing the boundaries of human knowledge. It's forcing us to rethink the fundamental nature of reality and our place in it.
It's all a bit overwhelming, honestly.
Okay.
I mean, the idea of multiple universes existing out there, maybe even with copies of ourselves, it's enough to make your head spin.
I know, it's truly mind-boggling.
Yeah.
But that's the beauty of cosmology.
Hmm.
It constantly challenges our perception of reality
Oh, yeah.
and invites us to explore the unknown with open minds and a sense of wonder.
So what do we do with all this information? I mean, it's fascinating.
Yeah.
But what are the practical implications of discovering a multiverse? Does it change our everyday lives?
That's a great question.
Yeah.
And one that's still up for debate.
Okay.
Some might argue that it has no direct impact on our daily lives.
Right.
But I think it's more than just a theoretical curiosity.
How so?
Understanding the possibility of a multiverse expands our philosophical and existential horizons. It challenges our assumptions about the uniqueness of our own existence and raises profound questions about the nature of reality itself.
Oh, okay.
It's like realizing that the world is much bigger than we initially thought. It doesn't change the ground we stand on,
Yeah.
but it profoundly shifts our perspective.
I can see that.
Yeah.
It's like finding out you have a long-lost sibling.
Hmm.
Your life doesn't necessarily change overnight,
Right.
but it adds a whole new layer of complexity and wonder to your family history.
Exactly.
Yeah.
And who knows, maybe in the future,
Yeah.
understanding the multiverse could lead to technological advancements
Hmm.
or even new forms of energy that we can't even fathom right now.
Wow.
After all, many groundbreaking scientific discoveries started as abstract theories
Right.
before they revolutionized our world.
That's a hopeful thought.
Yeah,
Okay, so we've covered a lot of ground here.
we have.
We've explored the standard explanations for the cold spot,
Right.
and we've ventured into the uncharted territory of the multiverse.
Yes.
I'm curious, where do you stand on all this? Do you lean towards any particular theory?
It's tough to say definitively. I'm captivated by the elegance and explanatory power of the multiverse theory,
Okay.
but I'm also a scientist. So
Right.
I need to see strong evidence before I fully embrace any idea,
Yeah.
no matter how intriguing it may be.
So you're keeping an open mind,
Yes.
but not jumping to conclusions.
Exactly.
Okay.
And I think that's the best approach for all of us.
Mm-hmm.
The search for the truth about the cold spot is a journey,
Right.
and we need to be open to unexpected twists and turns along the way.
You know, it's amazing how we started with this one strange cold spot and ended up talking about the possibility of entire other universes.
It really highlights how interconnected science is, like how one question can lead to a cascade of deeper and more complex questions.
Yeah, and how much we still don't know. I'm curious, what are the next steps in this cosmic detective story? Where do scientists go from here?
Well, for starters, we need more data. Scientists are constantly developing new and more powerful telescopes
Right.
that can observe the CMB in greater detail. Imagine trying to read a faded inscription on a distant wall.
Okay.
A more powerful telescope is like getting a stronger pair of glasses.
So we need a sharper image of the cosmic microwave background
Yeah.
to really understand what's going on?
Exactly. More precise measurements of the cold spot's temperature,
Okay.
size, and shape could help us rule out some theories
Hmm.
and strengthen others.
Okay.
And it's not just about the cold spot itself.
Right.
Scientists are also mapping the entire CMB with increasing precision,
Okay.
searching for other anomalies or patterns that might provide further clues about the early universe.
It's like putting together a giant cosmic jigsaw puzzle.
Yeah.
Each piece, even a tiny anomaly like the cold spot,
Right.
helps us see the bigger picture.
That's a great analogy.
Thank
And
you.
in addition to gathering more data,
Yeah.
we need to keep developing our theoretical models
Okay.
if the multiverse theory is correct.
Hmm.
It should have specific measurable consequences
Okay.
that we can test.
So it's a two-pronged approach.
Right.
Better observations and more refined theories.
Precisely. It's a dynamic interplay between observation and theory, constantly pushing each other forward.
Yeah, that makes sense.
Now, let's say, for the sake of argument,
Okay.
that the multiverse theory gains more traction in the coming years.
Right.
What are some of the mind-blowing implications?
Well, for one, I think it would completely change our understanding of reality.
Right.
We wouldn't just be inhabitants of one universe,
Yeah,
but part of a vast interconnected network of universes.
exactly. And it raises so many fascinating questions.
Yeah. Like what?
What are these other universes like? Are the laws of physics the same?
Right.
Could there be life out there?
Yeah.
Perhaps even intelligent life that's completely different from anything we can imagine.
I can't even begin to fathom what those other universes might hold. It's like opening a door to an infinite library of possibilities.
It's a truly humbling thought,
Yeah, it is.
and it highlights just how much we still have to learn.
Hmm.
Now, let's step back for a moment and consider what this all means for you, our listener.
Okay.
Why should you care about a mysterious cold spot billions of light years away?
That's a good question.
Yeah.
It's not like the cold spot is going to affect our daily lives, right?
Not directly, perhaps,
Okay.
but I think it's important to remember that science is about more than just practical applications.
Hmm.
It's about expanding our understanding of the universe and our place in it.
Right.
It's about satisfying our innate curiosity and pushing the boundaries of human knowledge.
Yeah, it's about the thrill of discovery. The
Yes.
awe of realizing how much more there is to the universe than we ever imagined.
Exactly. And the cold spot, with all its mysteries and potential implications, it's a perfect example of that.
Okay.
It's a reminder that we live in a vast and extraordinary universe,
Yeah.
one that's full of surprises.
Well, I think we've covered just about everything there is to know about the cold spot, at least for now.
We've certainly given you a lot to think about.
We have.
Yeah.
It's amazing how a patch of cold in the universe's afterglow can lead to such deep questions about reality itself.
Absolutely.
If there's one thing we hope you take away from this deep dive,
Hmm.
it's this. Never stop questioning, never stop exploring,
Keep learning.
and never underestimate the power of a single anomaly to challenge everything we think we know about the universe.
It's true.
Until next time, keep looking up and keep those curious minds engaged.